In this video, we will introduce the structure and functionality of the FedXplore framework. The researcher's workflow in FedXplore involves configuring the experiment parameters through a user interface. The user interface includes a dashboard for viewing runs and a sidebar menu with the Create Run option for launching experiments. We launch a small-scale federated averaging run on the SAFAR 10 dataset. The subsequent configuration steps define the main components of the run. In particular, the interface allows researchers to configure run logging. FedXplore supports integration with MLflow for visualizing the federated learning process. After all required parameters are specified, the run is launched using the generated CLI command. The run page provides access to the necessary run information. Let us move on to the MLflow experiment page. This page displays model metrics and system parameters. For example, one of the artifacts is a client participation histogram. The high-level structure assumes that all directions in FedXplore inherit from a core base object that defines the fundamental principles of federated learning. A base object is a package containing three modules: method, server, and client. The method and the server act as a central node, allowing the orchestration of the FL process. Clients perform local training and contribute model updates to the server. We can see that federated algorithms are a list of such packages. The base package contains the mentioned modules. The remaining packages inherit from it. Let's go to the main pipeline. Here we instantiate a dataset and pass it as an argument to a method. Then the method in the init federated function creates a core components: manager, client class, and server, and after that the client selector overrides the method logic accordingly. Finally, begin train method starts the training. In the train file, we see this logic with some technical additions. Let's move on to this pipeline. The begin train loop iterates over rounds. In this loop, we test the global model, select clients, determine each client's type, and start training. After training, the pipeline validates the received updates and aggregates it to the global model. At the end of the training, the manager stops the training by sending a signal to the clients. Train round loop iterates over batches of clients organized by the manager. At each iteration, the server determines and sends content to the client that specifies its learning. For example, a global model is sent to all clients. After local training, the server receives and parses content from clients. This could be validation loss functions, gradient updates, etc. Let's move on to the key directions of FedXplore. The slide shows an inheritance scheme of Byzantine-tolerant techniques. Along with the scheme, the Byzantine base package contains a sub-package of pre-aggregators, which are an add-on to the existing defense methods. It complements the aggregation function with the concept of trust scores to clients, which are coefficients in the weighted averaging of gradients. Along with defense methods, FedXplore allows you to flexibly define attacking setups. Client's attack types defines the type of attack. It supports 5 types and can be mixed with a list. We can also determine the percentage of attackers and the attack pattern. Client selectors follow an inheritance scheme presented on the slide and consist of the 2 core components. Select clients to train implements the logic of selecting clients in the training round, and change functionality complements the functionality of the aggregation algorithm. Let's consider the client strategy based on the power of choice algorithm. In select clients to train, we simply select from a random subset of all clients with the largest loss. However, this requires passing loss from the client to the server. So, in change functionality, we rework trainer parse communication content and client CLS get communication content. Finally, personalization methods define a customer personalization strategy for flexible setup customization. Thank you.